and welcome to today's video tutorial on identities and digits. Before we begin, I would like to tell you that I have made some changes in the background of our videos. Reason is that the last few videos were very boring. I mean, they had a very boring background, and every student likes to read something which is colorful, and because it makes a student understand things well. So good news for you. Let us start with the first topic, which is on identities. Now, an identity is any equation which is satisfied for any values of its variables. For example, if we have an equation which says a plus b is equal to b plus a, this equation is an example of identity. No matter what values you choose for a and b, this equation will always be satisfied. But in case of the equation ab is equal to under root ab, this equation is not an identity. The equation will not be satisfied for all the values of a and b. Now, how can we calculate 1007 square? We can of course multiply 1007 with 1007, but there is a way of calculating it without using a calculator. For that, we should need to know the identity, which is a plus b the whole square is equal to a square plus 2ab plus b square. It is derived by multiplying a plus b with a plus b. Now 1007 whole square can be written as 1000 plus 7 the whole square, which is equal to 1000 square plus 2 into 1000 into 7 plus 7 square. It gives us 1014049 as answer. Similarly, we can calculate 995 whole square by using the identity a minus b the whole square is equal to a square minus 2ab plus b square. Now 995 whole square can be written as 1000 minus 5 the whole square is equal to 1000,000, which is 1 million, minus 2 into 1000 into 5 plus 25, which is equal to 990,025. And you can cross check it with the help of a calculator. Now, how can we calculate 106 square minus 94 square? For this, we need to know the identity a square minus b square is equal to a plus b into a minus b. Now, 106 square minus 94 square can be written as 106 plus 94 into 106 minus 94, which is equal to 200 into 12, and this gives us 2400. Isn't it much better than calculating each and then arriving at an answer? Surely yes. Now, we need to remember the three identities in order to solve identity problems. First one is a plus b the whole square is equal to a square plus 2ab plus b square. Second is a minus b the whole square is equal to a square minus 2ab plus b square. And the third one is a square minus b square is equal to a plus b into a minus b. This will not only help you solve such problems, but will also help you in factorization of polynomials. Now let's move on to another topic, which is on digits. To understand problems based on digits, we first need to understand what place value is. Look at this number 6789.325. It has 7 digits, and each digit has a distinct place value. Now the digit 9 is in the units place, 8 in the tens place, 7 in the hundreds place, and 6 in the thousands place. The first digit after the decimal point is said to be in the tens place. For example, when we say 1/10 of the students in this class have scored A, that means 1 out of every 10. Now the second and third digits after the decimal point are in the hundredths and thousandths place respectively. The reason why we should know place value is that it helps us understand the number better. As 6 is in thousands place, the value it contributes towards the number is 6 into 1000, 7 contributes 7 times 100. Digit 8 contributes to 8 into 10, and digit 9 contributes 9 into 1. If we add these products, we should get 6, 7, 8, 9. The digits after the decimal point contribute something like this. The digit 3 being in the 10th place, the value it is going to contribute will be 3 into 1 by 10. 2 is in the 100th place, so we will multiply it with 1 by 100 and 5 with 1 by 1000. If we add all these up, we should get the value 6789.325. Kindly note a very important point. 8.75 is equal to 8.750, which is equal to 8.7500. The value of the number remains same or unchanged no matter how many zeros we add after the last non-zero digit after the decimal point. Now, if we have a question which says the units digit of a two-digit number is thrice that of the digit in the tens place. The sum of the digits is 8. Find the number. Now, first of all, do not overthink. You must know that the tens digit is 1, 2 or 3. It cannot be more than 3 because 4 into 3 is 12. And it is not possible to have two digits in the units place. Now let us consider the tens digit as x and units digit as 3x. As mentioned in the question, x plus 3x is equal to 8. If we simplify, we will get 4x is equal to 8, and hence x will be equal to 2. Our answer will be 26. Kindly note that the two digits number can be 13, 26 or 39. But since it is explicitly mentioned in the question that the sum of the two digits is 8, hence our answer will be 26. The next question says, how much is 17,628 rounded to the nearest thousand? To round the number off, we just need to know the digit to the right of its thousands place. If it is greater than or equal to 5, we will round up the digit in question and make the other digits to its right 0. If a digit to the right is less than 5, we will keep the digit in question as is and make the digits to its right 0. This is known as rounding down. In this question, we will round up the digit in the thousands place and our answer will be 18,000. How do we multiply 0.6 with 0.04? Let us ignore the decimal and multiply 6 with 4. 6 times 4 is 24. Now let us count the digits after the decimal point of each decimal fraction. 0.6 has one digit after the decimal point and 0.04 has two digits after the decimal point. That makes a total of 3 decimal digits after the decimal point. We will move the decimal point 3 digits to the left. Now we have 6 into 4 is 24. Moving 3 digits to the left, we get 0.024. Now how do we multiply 0.00000007 into 400,000? Let us write it down in powers of 10. As the first number has 8 digits after the decimal point, we can write it as 7 multiplied by 10 raised to the power minus 8. The second number is 400,000. and 400,000 has 5 zeros. So we can write it as 4 into 10 raised to the power 5. 7 multiplied by 4 makes 28, and using power law we get 10 power minus 3. So 28 into 10 power minus 3 is equal to 0.028. How do we divide 0.25 by 0.000005? Kindly note that we should always use powers of 10 approach whenever we have many digits after the decimal point. 0.25 can be written as 25 into 10 raised to the power minus 2, and 0.000005 can be written as 5 into 10 raised to the power minus 6. Simplifying it, we get 5 into 10 raised to the power 4, and our answer is 50,000. With this, we come to the end of our video on identities and digits. I hope you have understood it well. I'm going to upload the questions on these two topics after a day. If you want to score well, understand the mathematical concepts very well. This is the key to scoring good, scoring best in your GRE Quant. Goodbye for now and best of luck to you. Thank you very much.